Hello everybody, my name is Chris Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site. And in this video I'll be giving you an update on technical aspects to flight Alaska Airlines Flight 1282. So in this video I'll be covering the hinges, guide tracks and pins, securing the door plug, stop fittings, taking a look at some of the post-incident developments over the last week or so, then a recap on some other technical aspects including door warnings, the pressurisation system and why the flight deck door opened. As always, please treat your company training and their manuals as the authoritative source of information. So starting with the hinges, when a door plug option is fitted, it's not designed to be opened in service for any reason other than maintenance. The door plug is hinged at the bottom and opens outwards, as you can see in the photo. The door plug has got two large hinges at the bottom, and it can be held in the 15-degree open position by two straps near the top of the door plug. The lower attach points for the hinges are on a serrated plate. The attach bolts are on an eccentric attach system, and this allows the bottom of the door plug to move inwards and outwards slightly, as you can see here. There are lift assist springs on the hinges. These lift the door plug about 1.5 inches or just under 4 centimeters up the hinges. The lift assist springs make sure that the door plug will not fall back into the closed position when pushed open, and will help support the door plug during the inspection, removal and installation. This photo shows a lift assist spring in the extended position. The guide tracks and pins. So near the top of the door plug on each side is a J-shaped guide track. There's a corresponding roller pin for it on the door frame. These guide the door plug to the correct position when closing. When the roller pin is engaged in the track, this prevents any outward movement of the door plug. Note that the pins and tracks are mounted the opposite way to the other 4 passenger and service doors, overwing exits and cargo doors, all of which have got the pins on the door and the tracks on the frame, so the other way around to this particular door. When the door plug closes, the guide track meets the roller pin at the mouth of the track. Then as the door plug is pushed down, the track moves down onto the pin. To open the door plug, an upward force is needed to lift the guide tracks, which are on the door plug, off the guide pins. Securing the door plug. When the door plug is closed, it's locked in position by 4 bolts. These bolts prevent any vertical movement. 2 bolts go through the upper guide track fittings and 2 go through the lower hinge bracket assemblies. After the plug door is closed, locking bolts are inserted through the guide fittings to lock the roller pins in place in the closed position. These bolts prevent any vertical movement of the door plug. The locking bolts have got a castellated nut and a cotter pin or split pin, depending what you call it, through them to prevent them from escaping. There are 2 vertical movement arrestor bolts on the hinges at the bottom of the mid-exit door plugs. As the name suggests, these bolts prevent the springs from moving the door plug up the hinge guides. These locking bolts have also got a castellated nut and a cotter or split pin through them to prevent them from escaping. Stop fittings. There are 12 stop pins, which I've marked on the photograph around the door plug, and also 12 stop pads around the door frame. 6 on each on the forward and aft edges. The stop fittings, which is sort of the collective name for both the pads and the pins, are to transfer the pressure load from the door plug to the door frame. When the aircraft's unpressurized, the guide tracks and pins hold the door plug closed, and there's a slight gap between the stop pins and their stop pads. When the aircraft pressurizes, the door plug moves outboard slightly with the pressurization. This causes the stop pins on the door plug to touch the stop pads on the door frame. This is a close-up of a stop pin on the door plug. The contact point on the pins face outboard and the contact points on the stop pads face inboard. The locking wire around the stop pin that you see there is just to set its length and then hold it at that length. The gap must be on each of the 12 pins and pads must be equal to ensure that the pressure load is evenly distributed. When the door plug closes, the pins pass just above the pads. This enables the pins to travel past the pads until they're then lowered into position when the guide track moves down the guide pin. The stop pins pass over and past the pads, then down and slightly outboard to engage with the pads, as you can see on the animation there. When the door plug is closed, the door is pushed down against the springs as the roller pin travels up in the roller track. This causes the pins to come into close proximity to the pads. So they don't actually touch at this stage. That's when the aircraft's pressurised, but they're very close. As the aircraft pressurizes, the door moves outwards and the pins contact and push against the pads, taking the pressurization loads from the door plug to the door frame. So that's about the door mechanism and how that works. Let's take a little look at the post-incident developments. So on Monday 8th of January, during the NTSB briefing, Cliff Cruikshanks, an aerospace engineer and part of the agency's structure team, said that the exam to date has shown that the door did in fact translate upwards. All 12 stops became disengaged, allowing it to blow out of the fuselage. We found that both guide tracks on the plugs were fractured. We've not yet recovered the 4 bolts that restrain it from its vertical movement, and we have not yet determined if they existed there. That'll be determined when we take the plug to our lab in Washington, D.C. Boeing CEO David Calhoun said on CNBC News on the 12th of January that preliminary findings of the loose exit door plug assembly hardware at both Alaska and United Airlines are linked to a quality escape at Spirit. That's the description of what people are finding in their inspections, he said. We're not going to point fingers. Yes, it escaped our factory, but then it escaped ours too. So we're all in this together. And on the photograph, you can see I've marked the mid-cabin exit door plug on a 737 MAX 9. You can see that it's there installed by Spirit before it arrives at Boeing. So as for Boeing's actions, they announced on the 15th of January the following 5 new measures. First, there will be additional inspections throughout the build process of both Boeing and Spirit Aerosystems. Second, new in-factory training sessions will be introduced with teams of assembly line mechanics and engineers to gather and refocus on the fundamentals of the quality management system and re-emphasize the commitment to safety. Thirdly, Boeing will bring in an outside party to thoroughly review its quality management system and suggest further improvements. 4. Boeing will open the final assembly plant to any airline operating the MAX for additional oversight inspections. And last, Boeing will send more personnel to Spirit Aerosystems to strengthen their inspections, and they will not only inspect the installation of the door plug, but also 50 other items. The FAA actions commenced quite early on the 6th of January when they issued an emergency AD calling for inspections of all 737 MAX 9s with the door plug option. A few days after the inspection criteria appeared to tighten up, and this was presumably based on initial findings from operators of the type. The FAA is also considering having an independent third party, which it called a technical non-profit organisation, to work inside Boeing's factories to oversee quality and report back to the FAA. So the inspections, what have they uncovered? Well, these 2 photographs show an example of some of the things that have been found, and here you can see that the front well, the photograph on the left is the front of a guide roller pin plate, and you can see a loose fastener on there. And the photograph on the right is the back of that same plate and fastener, and you can see that the fastener hasn't come all the way through as it has in the upper one, the one that's in place securely. So that's just one example of things that have been found. That's say that there are probably other things found which I'm not privy to and I don't have photographs of, but this is one example. So just to say that it isn't all necessarily about the locking bolts. It could be, as in this case, about the plates that hold well, in this case the roller guides in place. So just a word about the 900ER. The door plug option is also available for that series. So a question remains why the FAA Emergency AD only applies to the MAX 9 with the door plug option and not the 900ER with the door plug option. The reason for that appears to be that since the 900ER has been out of production since Jan 2020, the type will have been through heavy maintenance, and therefore the door plug will have been inspected since leaving Boeing. That said, at least one airline has started making inspections to its fleet of 900ER door plugs, but at the time of recording this video, this isn't yet mandated by either AD or Boeing multi-operator message. So on to the other technical aspects. We'll start with the door warnings. A question was asked, did the pilots get any indication that the door was loose before it departed the aircraft? Well, certainly as regards door annunciations, no, they won't have done. And the reason for that is that aircraft with the door plug option have got the proximity sensors removed. Well, some people say they're removed, some say they're deactivated. I'm not quite sure which it is, but either way, they don't work. So the left mid-exit and right mid-exit captions are deactivated and should have in-op stickers over them. That therefore means that there would have been no door warning in the flight deck before or during the event. Pressurisation system. So what we know is that 4 weeks after taking delivery of the aircraft, Alaska Airlines sent the aircraft to AAR in Oklahoma for 10 days for Wi-Fi installation from the 27th of November to the 7th of December. And AAR have since stated that they did not open the door plugs. However, the aircraft had several pressurisation system problems following that Wi-Fi installation. They were on dates 7th of December 23, which is the date it left Oklahoma, 3rd of Jan 24 and 4th of Jan 24. Now, it's not yet known if these are related to that Wi-Fi installation or if other issues have been present since delivery. So let's look at what those pressurisation issues were. The NTSB said in the briefing that the aircraft had 3 auto-fail events in the weeks before the incident. I say it's not known if they're related to the mid-exit plug leaving the aircraft or not, but it could be. So let's just recap on the reasons for an auto-fail light. If it illuminates in amber, it's telling the flight crew that automatic pressurisation system failure has been detected. There are 2 versions of this, one with a corresponding green alternate light and one without. If the green alternate light is also illuminated with the auto fail light, that tells the crew that there's been a single controller failure. There are 2. The one in use, the primary one, and an alternate one. If the primary one fails, the system automatically flip-flops across to the alternate, and that is what the green light is telling you here. So pressurization is under control, and it's being handled normally by the alternate system. However, if that green alternate light is not on, then that means that the alternate system has not kicked in, pressurization is not under control, and the flight crew need to step in with the manual system. So there's been a dual controller failure here with auto fail light on its own and no alternate light illuminated. Reasons for the auto fail light. I kind of categorize these into two sort of families of reasons. First is that cabin altitude limits are being exceeded, and that is either that the cabin altitude rate of change is too high, by that means in excess of 2,000 sea level feet per minute. To give you an idea, the normal rate of change is 500 feet per minute. Or the cabin altitude is too high, and the limit is 15,800 feet for that. Again, just to put it into perspective for those of you not pilots or engineers on type, because I know some of you aren't who are watching these videos, the oxygen masks are deployed at 14,000 feet. The regulation says that the cabin altitude should not exceed 10,000 feet, and the normal cabin altitude is 8,000 feet. And the last reason could be that the cabin differential pressure is too high, and by that it means in excess of 8.75 psi. Other system failures could cause an auto fail, and they include power loss, presumably to the CPCs, the cabin pressure controllers, wiring failures, outflow valve component failures, or cabin pressure controller failure. Any of those total of 7 reasons can cause an auto fail light to illuminate. And lastly, the flight deck door opening. We know that it happened on the instant flight because the NTSB briefing mentioned it. But the flight deck door, not just the decompression blowout panels, opened as a result of this depressurization. And this appears to be an undocumented feature in both the FCOMs and the maintenance manual. The maintenance manual only says 2 things about it. One is that the door, the flight deck door, has got blowout panels installed that will open forwards in the event of a decompression in the control cabin, which wasn't the case because the AS1282 had a decompression in the main passenger cabin, which is the second statement. So in the case of a rapid decompression in the cabin compartment, the flight deck door is able to withstand the pressure difference due to the small area of the flight compartment, which obviously did not prove to be the case. The NTSB said in the briefing that Boeing will address the documentation to make reference to the fact that the flight deck door can and is in fact designed to open in the event of a cabin depressurization. That's it. That's the update complete. As always, if you've enjoyed the video, please give it a like. Subscribe to my channel if you haven't already done so. Thank you very much for watching.